Hello everyone, my name is Ryan Cartagena and this is part 2 of my presentation for Matrix Operations project. In this video I'm walking through my program, explaining each part of it, demonstrate how it works, and then talk about what I learned and the biggest challenges I've had while completing this assignment. The purpose of this project was to create a C program that can perform 4 main tasks: matrix addition or subtraction, matrix multiplication, matrix transpose, and solving simultaneous equations with 3 variables using Cramer's rule. The program interacts with the user, accepts matrix dimensions and values, verifies the dimensions are valid, and performs the selected operation and prints the results clearly on the screen. Some requirements for the program are to prompt the user for operation choice, validate matrix dimensions, accept input for each cell, perform chosen operation, use determinant function, and display the results. On this slide, you can see the very beginning of the program. First, the determinant 3x3 function is defined. This function calculates the determinant of the 3x3 function, and it is used later when we solve Cramer's rule. After that, the program enters the main function, displays a menu, and asks the user to choose an operation. The options include matrix addition or subtraction, multiplication, transpose, or solving a set of 3 equations. This slide also shows the beginning of option A, which handles addition and subtraction. On this slide, the program is inside the addition or subtraction section. Before it lets the user enter any matrix values, it checks the dimensions. Both matrices must have the same number of rows and columns to be added or subtracted. The program keeps asking until the user enters the matching dimensions. Once the size match, the program starts reading in all the values for matrix A using nested loops. Once matrix A has been entered, the program then moves on to filling in matrix B in the exact same way. Both matrices are filled. It asks the user whether they want to add or subtract matrix B from matrix A using either a plus or minus sign. Then the program goes through each element and performs the calculation. Each result is stored in matrix C. Here the program prints the final results of the addition or subtraction. Each value of matrix C is displayed in a neat format. Immediately after that, the program begins the multiplication section. Just like before, it checks the dimensions, but for multiplication, the rule is different. The number of columns in matrix A has to match the number of rows in matrix B. If they don't match, the user is asked again. After valid dimensions are entered, after the valid dimensions are entered for multiplication, the program reads in all the elements for matrix A and B. Then the multiplication begins. The program sets every value for matrix C to 0. This ensures that no leftover values interfere with the calculation. This slide shows the core of matrix multiplication. The program uses 3 nested loops to calculate the product. For each row of A and each column of B, it multiplies and accumulates the results into matrix C. After the multiplication is complete, the result matrix is printed. The bottom part of the slide shows the beginning of the transpose option, which is option C. And this slide shows the transpose section. The program first asks the user for the size of their matrix and then reads in all the values. To build the transpose, it simply flips the rows and columns, storing A into T. Finally, it prints the transpose matrix. At the end of this slide, you can see the start option D, which is for Cramer's rule. This is the last part of the code. and it shows Cramer's rules process. The program reads the 3x3 coefficient matrix A and then the three constants that make a vector B. It calculates the determinant of A. If the determinant is 0, the system doesn't have a unique solution. Otherwise, it builds three new matrices, AX, AY, and AZ. Each one replaces a different column of A with the vector B. The program finds the determinants of these modified matrices and applies Cramer's rule to solve for X, Y, and Z. Finally, it prints the three solutions. And so for what I learned, this project has taught me a lot about how C handles arrays and loops and helped me strengthen my overall programming skills. Throughout this assignment, I learned how to work with multi-dimensional arrays, validate user input to prevent errors, and implement mathematical operations manually rather than relying on built-in functions. I also learned how to break a larger program into smaller, more manageable parts, and how to create and call user-defined functions effectively. Overall, this project made me feel much more confident in writing structured and well-organized C programs. And for challenges and solutions, the biggest challenges I face in this project involve several key areas of the program. One major difficulty was implementing Cramer's rule, especially making sure I replaced the correct columns with the vector B, which I overcame by drawing the matrices out on paper to visualize the process. I also struggled with loop logic, since matrix multiplication required 3 nested loops and careful attention to index placement. Additionally, input formatting was a challenge because the user prompts had to match and provide examples exactly so frequently compared to my output to reference screenshots. And finally, printing matrices in a clean, readable way pushed me to learn proper formatting. These are my references. Use the provided Cramer's Rule sources, class notes, and Geeks for Geeks. And for my conclusion, overall, this project has helped me understand not just matrix operations, but also how to design larger programs in C. I learned about planning, debugging, and breaking complex tasks into smaller pieces. Thank you for watching my presentation.